Okay. Mm, Good evening. So we are going to cover the session number 3. So we have 3 sessions related to the engine. So that's last. Okay. So this is the last part that we're going to discuss related to the engine. Then we will be moving into the cooling system and ignition system. At the end of the ignition system, we'll be actually discussing about the engine management, the whole management of the engine. That includes the ignition system, fuel system, and lubrication system and cooling system as well. So all of these inputs from all of these actually uh, comes into the ignition engine management system. Then only it's actually decide the most corrective solutions to actually run the engine, right? So we'll move. uh, Okay, so principal operation of engine. So up to now we have discussed the classification, multi-stroke. So how the engine operate, combustion process, efficiencies, engine construction, and today we're going to discuss the last part, the lubrication system. Right. So we'll start from the beginning. I think you have seen the lubrication system in a hotel engine. So during your advanced levels. But if we consider about the lubrication system, it actually serves mainly 3 functions, right? Mainly 3 functions. Number one is reducing the friction between the surfaces, right? It's number one, or the first purpose of it is to reduce the friction between the surfaces, since there are metal components moving on metal components. That's going to create a lot of heat, as well as it's going to actually wear the components. To reduce this wear and heat generation, the lubrication is used. So lubrication, the thin film layer of lubrication is actually moving. And the second reason is cleaning and removing the debris from working surfaces, like small metal components, like very fine metal dust is actually removing in some cases. So these if these metals small metal component or small metal shreds, if they actually removed or stayed in the contacting surfaces, it's actually going to make the damage worse. So before that, it actually has to be removed. So this cleaning purpose, the removing of these parts is actually done by using the lubrication system. Since the lubrication system is actually flowing around the engine, it's actually removing the these debris or unwanted foreign objects, you could actually call like that. And the third function of this is actually the cleaning the components that difficult to reach. For one good example is inside of the piston itself. As we discussed in the previous lecture, the lubricant is actually provided to the inside surfaces of the piston itself, because the piston is getting heat, but it's almost impossible to provide coolant, or that means our water coolant into the piston, because of the complexity of working mechanism. So in because of that, lubricant is used to actually cool these surfaces, this piston, inside of piston, especially inside of the piston, is actually cooled by using the lubricant, right? So that's one of the reasons for this lubricant. In some cases, some vehicles, the lubrication system needs to be actually properly cooled, right? It has to have a separate radiator and need to be cooled because of this reason. In addition to that, right, in addition to these 3 main functions, it's also, it's also absorb shock loads, right? Shock loads absorption. The what that means is, I'll explain this again a few slides later. But what it means is, since this oil or lubricant is actually acting as a thin layer between two surfaces, the compressibility of this liquid oil, right? This oil is actually absorbing some of the shock loads or some of the loads acting on the components, right? In addition to that, contaminants such as, for example, carbon deposits, very small carbon particles that actually stays, that sometimes actually grows on the cylinder wall itself. These sort of things will be small particles, contaminants will be actually absorbed by the lubrication system or the lubricant itself, right? Then this lubrication system, while it is recirculation, some of these components will be actually taken, filtered. Some of these particles will be filtered. So the lubrication system is actually using a phenomenon known as hydrodynamic lubrication inside of the vehicle, right? Hydrodynamic lubrication, right? So what it does is a pressurized fluid layer, right? Pressurized fluid layer. Fluid is actually the lubricant that we are using, will be actually kept in between two surfaces. So the image shown here, right? The first image shown here is actually showing a main journal. So this circle is the main journal. So the lubricant, and this is the journal caps, right? This is journal cap, and this one is your crankcase, right? This is the crankcase, and this is your journal cap, and you have the main journal here. So the lubricant is the pressurized lubricant. In this case, the pressurized lubricant is actually filled here, right? Pressurized lubricant is actually filled here. So this creates a barrier between these two metal surfaces, right? These two metal surfaces. So that helps to reduce the contacts while absorption the loads, because when the piston is moving, right? When the piston is moving, the load is actually transferred up to the crankshaft. That load, then it will be transferred to the loads, actually the thrust load will be actually transferred to this crankcase. But before it goes to the crankcase, it actually has to travel through this lubricant, right? Travel through this lubricant. Since lubricant is bit compressible, right? So this compressibility of this lubricant, this property of lubricant, it's allow it to actually absorb the load, right? Load created by the combustion itself, right? That's what I actually meant by over there in the um, first slide. So the purpose of this lubrication system, by using the lubrication system, it's actually reduces the engine's weight drastically. So if you needs to have like ball bearing or roll bearing type lubrication system, it's going to add additional components, not to mention those components will actually wear out, right? Not to mention those components will actually wear out. So that is not the best solution. That's why most of these vehicles actually have this hydrodynamic lubrication system. So this hydrodynamic lubrication system can actually take a lot of load, because as long as you can actually increase uh, the pressure of the lubrication system, and if you can maintain these gaps exactly correctly, so these gaps needs to be very well measured and machined in order for these to work perfectly. So that's one of the difficulties in these sort of lubrication systems. But if you consider like the first engines or the first vehicles manufactured was actually using other types. So that means ball bearing or roll bearing type lubrication bearing systems, instead of using hydrodynamic lubrication everywhere. But later with the machining developments, these sort of system or this hydrodynamic lubrication system was applied and used in most of the vehicles, right? So this is how the load, the force of the load is actually absorbed by the lubrication. So even though expect this, so assuming this is actually the cross section of the crankshaft main journal, right? Even though we expect this crankshaft main journal not to move, it actually moves. Even though it's not this much of a drastic move, we can't even see it. But this movement, right? This movement slows down while it is moving, and it's thin out this film layer, right? While it is actually rotating also, this movement keep going, because this movement, right, this movement is actually forced by two forces. One is downward, other one is actually sideways, right? This is how the piston is actually forced from the piston. So even though piston is moving up and down, right, piston is moving up and down, right, but the connecting rod is not moving up and down. It goes on a movement like this. It's going on an angle, right? So that force is transferred into two sections. So one is downwards, other one is sideways. When it is going other way around, it goes like this way or reverse wise, and that way, right? So these forces move the crankshaft around, but it's not, we can't actually see it, but this movement will be uh, cushioned, and the cushioned by the lubrication system, and it would not actually allow this contact or this journal to touch the bearing itself. So you can, if you can clearly see here, there's no contact between these. There's a gap, always there's a gap. Sorry, that one is too much. There's always a small gap, right? There's always a small gap. That's how the hydrodynamic lubrication system actually works. So there are two types of lubrication systems that is in use. One is known as the premixed lubrication system, where the lubricant, right? Lubricant is actually mixed into the fuel itself, right? Into the fuel itself. And the other one is pressurized lubrication system. So pressurized lubrication system is the one we usually discuss. Premixed lubrication system is used in mostly in the two-stroke engines, right? Two-stroke engines. So how this type of lubrication system works, it's actually send these fuel and lubricant particles together, right? So lubricant particles and fuel particles are actually mixed, or fuel and lubricant are mixed before it comes into the combustion chamber, right? When it comes to the combustion chamber, this is actually a mist now, since lubricant is not coming as a complete flow, it's actually mixed with the air, so it's a mist. So this mist goes and it stays in the, sorry, so once it goes into the combustion chamber, it goes and it's going to be absorbed to the, or adhere, the word is actually adhere to the piston wall itself, or piston wall, or cylinder wall, sorry, cylinder wall itself. So now cylinder is actually having lubrication, but the disadvantage of this system is, number one is you don't know whether everywhere is exactly lubricated. So we can't exactly sure that all the places are going to be lubricated very well, right? Number two is, since lubrication, since that is problem, it has to have, you have to give a little bit more lubricant, right? And the some of these lubricants is still going to be remaining with the fuel itself. So this mist is going to be remaining with the fuel, and it's going to actually combust and going to come join the exhaust as CO and HC, or carbon monoxide and hydrocarbon, right? So engine oil is actually a hydrocarbon, so it's actually going to join to the exhaust as hydrocarbon and carbon monoxide. So the two-stroke engine is going to have bit more emission than a normal engine. So that's one of the main reasons for banning the two-stroke engines in most of the countries too. So the other system is pressurized lubrication system. In pressurized lubrication system, instead of actually giving or sending the lubricant through this uh, airfoil mixture, they actually, what they do is they pump oil through here, right, through here into the piston itself. Then from piston it goes out from these cylinders, right, from these cylinders. I put it on the wrong cylinder, but goes out from the, so I put it out from the wrong ring, but it comes out from this ring. There's a small holes. There are holes in the ring land. So in those ring lands, the oil is actually coming out and it lubricates the whole wall, right, cylinder wall. In addition to that, right, in addition to that, some cylinder engines actually have a lubricant or oil squirter system. Squirter system means pressurized oil is actually sprayed from the underneath of the piston itself. That's also helps the cooling as well. Uh, in addition to helping the cylinder lubrication, it also helps the cooling of the piston itself. So this system actually comes under this pressurized lubrication system. That comes under this pressurized lubrication system. So lubrication system can be actually classified even further with a different type, pre-mixed and mixed type. There's different types, right? Different types, especially for these two-stroke engines. They have in some cases, like three-wheelers, you actually have to add the lubricant with fuel, but there are some systems you can just add lubricant separately into a separate tank that will actually mixed, or that will actually inject into the intake itself separately. So anyway, the final outcome or final lubrication system is still a premixed lubrication system. So now we have pre-mixed lubrication system and pressurized lubrication system. So pre-mixed lubrication system is not using pressurized pressure to actually lubricate the system. So this is mostly used for smaller engines and two-stroke engines, right? So in these sort of cases, there's no like two-stroke bike engine sort of applications. Crankshaft system, crankshaft and these connecting pins do not need the lubrication that much. Being the reason being, these are actually using ball bearing times. When there's only one cylinder, there's no point of having like a advanced or pressurized fuel or oil system just to lubricant this part over here, right? Or this part means the piston and the other components here, especially in the two-stroke engine where you don't actually have valves. But in a four-stroke engine, especially in a four-stroke engine, there's valves operating, and so valve system needs lubrication. So in such case, the high pressurized lubrication system is being used. In other applications, the for pressurized lubrication system is very rarely being used. So since having one cylinder, there's no point of having a lubricant or hydrodynamic lubrication for the piston or the crankshaft itself. Also, in these cases, we can just use ball bearing lubricant, ball bearing crankshaft. That also makes sense. Yeah, so in the pressurized lubrication system, we actually have two types known as wet sump lubrication system and dry sump lubrication system. The difference between these two actually comes down to how these systems operate and what are the limits between these two systems. Basically, the outline system of both of these systems are same, right? The system operation wise, both are same except for one one main difference. So we'll start like pressurized lubrication system. So why two-stroke engines low efficiency? I did 2-stroke 200cc bike. I fill 1 liter and I ride only 12 to 17 kilo. Okay, so what do you mean by low efficiency? You mean high fuel consumption, right? So according to what your question I can understand is you have high fuel consumption. That's what I can mean. I can understand. So if it is the question you are asking, the reason being in two-stroke engines, you have to give twice as more fuel as a four-stroke engine, because for every in a four-stroke engine, for every 4 strokes, you only have to give 1 time fuel, but in a two-stroke engine, for every 2 times you have to give fuel. So you need more fuel in this thing. I guess that's the reason he's he's asking. It has a power valve system. So what is this bike? Is 200? What is this bike? 200 bike? Two-stroke engine, 200cc bike. I'm not exactly sure what's your question is. Anirudh, if you can clarify the questions with more details, I may be able to do that. Right. So we go to the pressurized lubrication system. So we'll just discuss about pressurized lubrication system. Then we'll see the difference between the wet sump and dry sump lubrication system. So pressurized lubrication system is the idea of the lubrication system is very much simple actually. So what it does is, as shown in this image, first I will actually use this image shown here, this colored image, because it's a bit cleaner. So you have fuel in the bottom of your engine, that means in the fuel sump, oil sump. Then oil is actually sucked through a pump, then it is pressurized, right? Then it is pressurized to a predetermined value that's around from it actually varies from engine to engine. The varies from 25 psi to 65 psi usually, but for healthy engine it should have at least over 40 psi's, right? So this lubricant then passes through a filter itself, where it actually filters out any contaminants or any debris in there and send this lubricant into a component or a part called the oil galleries, right? These are actually called as oil galleries. So these oil galleries are located in the engine block itself. So in addition to all the components, we can actually see the coolant, jackets and everything. There are horizontal lines. These are actually horizontal channels that is actually constructed inside the engine block itself. These are actually the places the oil is being distributed. So for all the other places, oil has to be supplied. These actually went through here, right? So all the other places means some lines are surely, some of these lubricant lines are going and connecting or supplying the lubricant to the uh, crankshaft journals itself. From the journals or through the journals, then the lubricant is supplied to the pistons, I mean the connecting rod, then from connecting from rod then to the piston itself. And from there, from the journal itself, sorry, from the gallery itself, there's another line that sends the pressurized engine oil into the head, right? Head means there you have the valve, crank, camshaft. All of these places also get in the lubricant. That lubricant, right? That lubricant finally again with the gravity, once it's actually consumed, so once its lubrication purpose is done, it's actually returned back to the sump with gravity fed. So now the system is gravity fed. After going up to the correct location, it's afterwards it's actually gravity. So here also the same in this. In here also, once the lubrication is actually came to the crankshaft itself, if the lubricant is not passing to the pistons itself, the rest of the lubricant, the remaining lubricants actually leak out, right? Remaining lubricant is actually leaking out, and it return back to the sump itself, oil pan itself, right? So that's the path. So the oil is absorbed, then supplied, then pressurized, sent to the filter, then it goes to the gallery itself. From gallery is distributed to each and every component. Lubrication is necessary. After the lubricant purpose is done, the lubricant will be gravity fed or fed or returned back to the oil pan or oil sump itself. So that's what actually shown here. That's what actually shown here. As you can see, the lubricant and the oil pump is there. In addition to this, oil filter is there. It goes up to here. So this is the sorry, is the gallery. So from gallery, each and every component is actually getting lubrication. So you can see from through the connecting rods, through the crankshaft is getting to the connecting rods, and up to the gear wheels also. So in this case, the timing gears are using timing gears. So same here for the first image if you go. So the lubrication has to come up to this chain as well, right? Timing chain also has to be lubrication. So all of these components that are metal to metal contact will be lubricated with this method, right? So in addition to that, there will be a pressure valve. It's actually not, oh yeah, it's actually shown here. So protected by a pressure relief valve. So this pressure relief valve is actually some small spring loaded valve inbuilt with the gear or this pump, this oil pump itself. What it does is, so as you know, engine operate in different RPM. So when the engine RPM goes higher than predetermined value, or more than, when the RPM increases, that will automatically increase the lubricant pressurize of the system. So it may go than the necessary values. That means, for example, here if it goes more than 65 psi, this spring load valve is going to be open at 65 psi. So as soon as it comes below 65 psi, again the valve will be closed. The system will always maintain the same pressure, even with different um, even with the different RPM. So that's why this pressure relief valve is there. So it's actually inbuilt in the pump itself. There's no point of actually building it in somewhere else. So in addition to that, there will be a gauge actually showing the pressure. So as seen here, either gauge or light, it could be either one. So both are actually working very much similar to others. So but this gauge, the reading for this gauge always has to be taken from this gallery itself, not from anywhere else, right? So that is the only place to take the reading. So if you look at any engine, if you can find the pressure switch or the pressure gauge pressure gauge sensing unit, so that is where your gallery will be. Okay, so once everything is completed, so you have something like this. So the difference between the previous one and this one, oh, so difference between this one and the previous one is, this one actually use a separate type of pump. This one actually use a external gear, but the previous one is actually using, I think, I can't remember. Wait, just me check. I'm gonna go back. Yes, this one is actually using a internal gear pump. So this one is using a external gear pump. So yeah, so as I told you earlier, you can see the fuel. So oil is actually comes back, and you have the pressure relief valve here. So as you can see, this is the spring. Actually, it's a spring loaded system. The oil is actually provided into this oil filter. From oil filter, it's the filtered oil will be actually sent back to the gallery itself. right? Gallery itself. So gallery itself, yes, I missed one place. Yes, oh, gallery itself, and yes, this one is the pressure gauge sensor unit here. In addition to that, you have a oil cooler here. As I told you earlier, there's some, in some cases oil coolers are used. So in oil cooler you have a valve here, right? This is not a valve used in all the engines, only in some particular engines this is used. So here what it does is, in this particular components, the oil cooler valve is very much similar to the thermostat valve used in the engine cooling system. What it does is, once it, if it is the, if the oil uh, temperature raises that more than a certain value, it will actually, this valve will be actually opening the pressure. The lubricant will actually send certain set of the oil will be actually sent back through the cooler itself, and it return back to the oil pan, oil sump itself. So by doing so, the lubricant's temperature can be reduced. So that is the purpose of this system. Hope you all got it. So before I go into this wet sump and dry sump system, the problem, actually there are two problems with these lubrication systems. So disadvantages is because of this normal pressurized lubrication system. So yes, I forgot to tell you. So these sort of lubricant system, right? These sort of lubricant system where the lubricant or the whole oil, right? Lubrication oil is actually filled in the engine sump itself at all times, is known as a wet oil system. And the disadvantage of a wet oil sump system comes next. So the problem here is uh, lubricant return is actually gravity, right? Lubricant return line is going to be gravity fed. So the lubricant has to be always slowly returned back to the uh, sump itself. It's going to take a little bit of time because, as you know, these are viscous, somewhat thicker fluid, so it takes some time to flow. Eh, in normal application, this is fine. If you are driving normally, it's actually fine. But when you are driving hard, if you are taking a lot of turns and if you are braking and accelerating very fast, this causes the fluid or the lubricant to move, right? This causes the lubricant to move, right? So for example, if the engine is here, right, now you can actually see this car is somewhat angled, right? So that means the lubricant, even though when the vehicle is actually moving, the lubricant still try to keep that, it's actually also moving with that. So this movement, right, this movement goes with the speed and the change of direction. This is going to be higher. This is due to the slosh. So oil is actually sloshing to one side to other side, front to back, side to side, right? And these engine oil pans are not that deep. So if the oil pans are deeper, then these can actually manage it. They can actually they won't be having that much of problem, because if it is deeper, then uh, still the angle it's need to achieve in order for not in order to start the engine is higher. But in most cases, as the engine has to be mounted as much as low as possible, the lubricant or the this sumps depth is very limited. So in such cases, engine could end up having oil starvation or not having any oil. So this could actually result in a big problem. So to fix this, right, to fix these what the reason to fix this, there was a system used. So one good example is this sort of very hardcore sport application. So as you can see, the lateral acceleration. So in this case, the acceleration is this way, but vehicle movement, sorry, vehicle direction is this way, but vehicle moving is this way. So the lateral acceleration in somewhere is in between these two directions. So as a result of that, right, oil is actually moving other way, other direction. Oil is trying to resist this movement. So if you look at the oil pan should have something like this, right? Oil sump, it should have some shape like this, right? So that means if the oil pickup point or the oil absorbing point, this oil stainer, if it is close to this corner, right, at that particular time, there will not be any lubricant available in the engine to cushion the system, especially in such application like this where the engines are working very hard. This could end up fatal to the um, engine. Anyway, so as a fix to this, right, as a method to fix all of these issues, then another system was actually developed, which is actually known as dry sump lubrication system. So dry sump lubrication system and wet sump lubrication system is actually shown here. The only difference between these two systems is, right, so if I start, well, I'll start from this one, I think as better. So you have oil sump here. From oil sump, oil is actually absorbed through the oil pump. So this one is oil pump. Then it is actually pressurized, right? If the pressurized system's pressure is too high, this line, this pressure regulator valve or the pressure relief valve will open, the oil will actually return. Assuming that oil is actually oil is properly filtered, oil is properly pressurized, then oil is actually sent back to all the components, filters and everything. So don't worry about this section, I'll explain this one later on, right? So this is what the usual system, this is how the usual wet sump lubrication system works. But in the dry sump, it's bit different, right? So again, you have the engine sump, right? So, but you don't have oil here. Whenever once the engine is running, the lubricant actually goes, pressurized system is still pressurized system. The lubricant is actually comes through with the gravity fed, it comes back to the sump. That lubricant is actually scavenged, right? That lubricant is actually scavenged through another scavenging pump. So this one is scavenging pump. That pump scavenges the fuel, oil, then it sent back to a separate tank, right? It's actually sent to a separate tank installed somewhere in the engine bay or inside the vehicle. But this tank is not the difference between this tank and the oil sump or this wet sump is, this is actually a thin tall tank, right? This is a thin tall tank that can actually hold more oil, right? More oil. Then from that oil tank, bottom of that oil tank, a feed line is sent back to the oil pump itself, right? Oil pump itself. Then from that only it actually goes to the engine components again, right? So the advantage of this system is this system can actually deliver high pressure, as well as it can actually it can operate in almost any condition, right? Almost any condition. It does not matter how much of lateral acceleration is felt by the vehicle, as much because the lubrication or the lubricant tank or this supply tank, separate tank that holds engine oil, that volume of that can be increased. But in this case, in the wet sump, it's actually very much limited. So it's not actually affected by the lateral acceleration. But there are some trade-offs. So the main issue with this system is this dry sump system. it's very expensive and it's need more additional components and piping. So it's going to actually be heavier, right? It's going to be heavier. So consumes bit more power as well because it need to run a different pumps. In addition to the usual pump, it's actually have to have run another pump. So it's going to increase the it's actually needs, it's actually going to increase the power or engine power consumption from this. So yeah, so that's the main advantage of this system, but it's not actually simple as it seems. But if we go to the next slide, I think you guys can see it. So this is actually a operating dry sump lubrication system. It's not simple as it's the shown in previous image. So I'll explain with this photo, right? So as I told you earlier, these are mostly used for this high performance application. So the engine seems fine. It looks like the normal engine, but in addition to that, you can see there's a tank here, right? So this is the additional tank I told you earlier that will be holding the lubricant, right? That lubricant will be held in. So there's another tank here, which I'll come to you next, right? So the pump, the second pump, right? There'll be a pump additional. So that pump is this one over here. Wait, I think you guys can't see it. So this is that additional pump, right? So it's actually additional extra pump that is driven by a belt through the crankshaft, right? So crankshaft, so that means that additional pump, right? So now this pump is actually shown here, right? That pump is actually shown here, right? But if you can see, there's more than one line, one feed line is actually goes back to the tank itself. The reason being is, as you can see over here, right, lubricant is not actually absorbed from the one location. It's absorbing from few locations with few pumps. As the engine sump is longer, as much as possible the lubricant has to be absorbed. So that's why it's actually having separate or three absorption locations in the sump itself. So all of these based on how the lubricant is flowing from the top of the engine to the back, these locations are decided. Then from each location, it actually has to be pumped back, and those oil is returned to the tank itself. But in this case, instead of having four lines, it's only having one single line, right? One single line, right? But there's one more line is missing in this image. There should be another line goes from here to here, this line over here, right? This covered cup sort of. So that's what actually the return, the oil that filled in the tank, that will be fed back to the pump again. So this one is actually called as a modular pump. You can actually add more pumps behind this if you want to increase the scavenging effect. So one of these pumps actually used as a return or pressurizing system as well. So one of these, let me check which one. Okay, the last one. So the last one, the pump oil is comes this way, goes through the pump. Oh, this color is not good. Blue. So now lubricant from the separate tank goes back to the pump, and it's pressurized. That pressurized oil is actually next sent through another filter. Another filter means the filter itself. Then it goes to the engine oil gallery, right? Engine oil gallery. So this is how the normal dry sump lubrication system is actually working, right? As I told you earlier, this breather system, this tank or this one, right? It's actually called as a breather tank, right? It's actually called as a breather tank. So the purpose of having this tank is, as you can see, there's oil lubricant line feeding into this tank. So all the time lubricant is circulating in this tank. So it's going to create a sort of like a pressure because of the vaporized lubricant. So that vaporized lubricant pressure has to be actually sent out, or that pressure has to be vented out, but venting it outside is not advisable because of the emission. So as a result of that that lubricant vent is actually sent through something called a breather tank. The difference, the advantage of this tank is this lubricant that vent actually gets the vaporized lubricant. Here it's actually have sort of like a filtering system where it's actually separate the oil itself. Only exhaust is air, right? It's only have air outlets. No vaporized oil is actually coming out from this. So that's why it's actually using this tank. Instead of using this tank, then it's possible to just have this breather line or this open here, also keep it open here, but that could end up venting lubricant oil, so which is not the ideal solution, right? Okay, so that's what the dry sump lubrication system. We'll move to a more simple thing, like what are the components of the lubrication system. I know you have learned these things again, so I'll just go through some of the components. So you have the oil sump, oil pump, pickup screen, pressure regulator, and oil filter, right? Oil filter, you have oil filter, bypass valve, you have a bypass valve separately, oil galleries, oil galleries over there, and dipstick pressure indicator. So dipstick, you know what is a dipstick? That is that small stick sort of thing that we use to actually see and identify where the what is the oil level is. And oil gallery we already discussed. Oil filter we have discussed. We'll go through that. Oil sump is the bottom tank, right? This bottom tank that holds the lubricant here, right? That holds the lubricant here. And in this image, you can actually see very well how tall the lubricant tank is, or the sump is. So, and it is actually narrow in this case, but because of this, it could actually change into such a direction, rendering this whole system useless. Anyway, so sump is usually made of pressed steel or aluminum, or now most in modern cases it's actually made with thermoplastic that can withstand the temperature of the engine. It just have to hold the lubricant. It does not matter whether it's made of plastic or metal. There's not much of an advantage with both of them. So next we'll move to the other components. Yeah. So the lubricant pumps. So usually these are actually driven by the engine crankshaft itself, mostly gear driven or chain driven or timing belt driven. In some cases, like the previous application we discussed of the dry sump system, they will have a separate driving system. So in these, this is the most common types used in the internal gear pump and the external gear pump. So usually gear pumps are used for lubricant pumps because of the high viscosity with these. So this pump can actually generate a bit of, we call this as positive displacement pumps. So any of these positive displacement pumps can be used, but the main reason for using these sort of gear pumps is to reduce the space necessary for using the space necessary for the pump itself. So there's not much of an advantage either one, but as you can see here, this one can actually generate bit more flow rate. So main difference basically flow rate and the pressure it can reach. This can reach higher pressure, this will reach a bit lower pressure. That sort of a small differences are there, but at this level it's not important for you guys. So yeah, so we have filters next. Lubricant filter, there are two types of filters actually. I don't know whether you guys known about these things. One is actually cartridge type, the other one is actually known as the uh, spin-off type, right? So let me type, I forgot type. So this type of lubricant oil filters are known as spin-off. Right, and the other one cartridge type. So the difference between these two is when you remove this filter, the spin-off filter, you take this filter, the whole filter itself. But in the cartridge type filter, usually only the inner element will you can only take. The outside housing you can't take. So unfortunately, this image is not clear enough. If there's a small hole here, once this is open, right? Once this is open, this cup will open. The whole filter will not open, only a cup. There will be a small opening. From that, you can actually take out the cartridge itself. So this cartridge type mostly used in German and European vehicles or European vehicles, but now Japanese manufacturers are also moving towards this type of lubricant pumps. One of the main reasons for this is to reduce the consumption of materials, because for every time you have to have this material instead of just you can use the housing, or sorry, instead of you can just use the filtering element itself with this method, or cartridge type, in the cartridge type. Anyway, um, based on the flow, right? Based on the flow, how this oil lubricant filter is actually flowing through the filter, there are two types, right? There are two types. Yes. Before I actually go there, I have to explain this. Usually, most people think actually lubricant is sent first, goes through the middle of the filter and it's actually returned from the outside, but it's not the case. It's actually other way around. Well, lubricant is actually comes through outside and then it goes through the inside of that. So the filtered lubricant is actually going from this center hole here, this center section here, right? So that's the usual flow impact, but most people think it goes through the most people think it's actually goes through the middle, and the output or outside outlet is actually coming from the outside. It's not the way, it's the way round. So these are actually microporous paper filters. These are actually paper filters. These used to remove very small particles. If we go to the next slide, so as I told you earlier, there are two types of oil flowing systems based on the filter. So one is full flow system, the other one is bypass flow system. So in the full flow system, complete oil flow is going through a filtering process, right? But in the bypass system, it's half of the lubricant, only portion of the lubricant will actually always go through the filter, right? Both are same. I have to remove this. Both systems are very much both types of filters are very uh, effective, but as you would guess, full flow system is bit more effective. But in the full flow system, the pump has to have higher pressures. It needs to maintain higher pressures in order to push all the fluid through the filter and maintain the pressure inside the whole system. But in the chorus or in the other system, it can actually get away with little bit lower pressures. But in the filter wise, the both filters are not the same. But full flow system, the filter is with chorus, so it's the holes are somewhat bigger than the filtering holes in the filter mesh itself is somewhat small amount bigger than the ones used in the bypassed full lubricant system. Both systems actually being used. Both systems are being used in different vehicles. So next we goes to the pressure indicator. So this is one of the most important parts of a vehicle. So most people do not care about this as long as there is no meter. Most people think it's okay, but it does not matter whether this gauge or this light, right? If the is it whether this gauge or light. So if it is a gauge like this, if it goes below this middle indicator, that means you don't have enough lubricant pressure since it is 40. And if you have this light, if it is switched on once you start the engine, that means your lubrication system has some problem, right? So either one of these things you need to check the engine as soon as possible before it make a catastrophic damage to the engine, right? So lights turn on the gauge, reach low pressure, drops below specified level 10 psi or 7 kilograms square centimeter. So also oil pressure is between 40 and 60 psi. Common causes of low oil pressure are low oil level, worn out pump, and worn out lubricant. So low oil level means the system is not getting enough lubricant, so it could not actually maintain the pressure in the system because it can't pump. Worn out pump means the pump is the gears between the pumps are worn out, so the pump could not actually deliver necessary pressure. This happens very rarely, especially because this lubricant pump is actually working with lubricant, so it's always very well lubricated. So next part is worn out lubricant. That means if the engine is using very old lubricant oil, the lubricant oil may not have enough viscosity to obtain the necessary pressure. In such case also, pressure indicator will turn on, right? So in case sometimes the lubrication light or this indicator may come low at lower temperatures, so once you start, but after accelerating a little bit, it may come up to a understand operating or accepted level. In such case, it could be either worn out oil pump or it could be a worn out lubricant. So either one you actually have to replace the lubricant or the pump itself. So yeah, next we need to just learn about how this system actually, this indication system works. It's very simple. So what it actually have is so this part is the pressure sending unit, right? So this part is the pressure sending unit. So it actually has an open, right? It's actually has an opening which connect to the oil gallery itself. So the lubricant actually comes through, right, through here and filled up to this one over here, right? So when lubricant is actually filled based on the pressure, right? Based on the pressure, this diaphragm over here, right? This one over here, right? Oil pressure acting diaphragm. So this diaphragm moves, right? That diaphragm moves, which causing the this sliding contact to move inside of this sender unit, which in turns actually change the resistance. Change the resistance. When the resistance is actually changing, the voltage between these two are going to change. So there are two coils in between these two. These coils actually causes for a magnetic level. So that magnetism actually causes this needle to actually move a little bit, right? So this is actually what you have the gauge indicate, right? So this is again, I need to remind you, this is just a very old application. This is not how the modern application works. It's uses a completely a different approach. We will discuss in your last module of this last lesson of this module, which is electrical systems. So here you have the search, and the battery is actually here. So the power is comes through the battery switch, and the whole system will be actually uh, this whole system will be actually what you call this, energized. Whole system is energized, and there's a what do you call this, voltage divider circuit. So this is actually working as a voltage divider circuit. This change of resistance actually caused change of resistance between these two coils, which ended up causing a different magnetic levels, which end up moving the needle based on the movement of this pressure acting diaphragm itself, right? So this is how this gauge actually, if there's a gauge, that's how it works, right? But in some cases, or most of the modern vehicles actually do not have this gauge, because you don't need to know the gauge, you just need to know whether the lubrication system is perfectly working or not. So in such cases, again, still you have the battery. From the battery ignition switch, once the ignition switch switched on, the power goes to a bulb, right? Indicator bulb. So this is the light over here. Then that burning light in the dashboard again goes to earth. So that earth wire, right, or the negative connection of this bulb actually goes to a oil pressure switch, right? Oil pressure switch. So again, this oil pressure switch is actually connected to the oil gallery itself. So the oil pressure is actually delivered through this hole up to this level, right? And there is a how do I say, spring loaded diaphragm again, right? Diaphragm again. So if the system is working, right? If the system is working properly, that means this light should be switched off. So once the lubrication system is fully pressurized, this diaphragm will move back, right? Contacting with the earth line, right? This will contact with the earth of the body of the oil pressure switch, which is connected to the engine itself. Engine is actually connected to the battery uh, negative terminal. So when this diaphragm moved, it will actually turn off, right? Once this move, right? Once this um, diaphragm move, that will actually turn off the signal, right? So when the pressure is there, there's no connection between these two contacts and the ground points, right? There's no contact between this spring and the ground points. So there's no light switched on. But if the pressure is dropping, if the pressure is not enough, that means if the pressure could not overtake the pressure or force acting from this spring itself, in that case, this pressure spring will actually open, or it will push back and it will contact this line, and the light will turn on. right? That's how this light is actually work. Very simple, very simple. So finally, we just actually have discussed lubricant, right? Lubricant. So yeah, so lubricant actually is the, we can call it as the lifeblood of the engine. So as long as lubricant is there in the engine, nothing will happen to the engine as long as you cool the engine properly, right? So engine oils are actually made with, oh, I forgot to do that. So engine oils are actually made with hydrocarbons, right? Hydrocarbons mostly used using or taken out from this crude oil, right? Crude oil. Good. So even though it's actually taken out from the crude oil, its lubricant should have some properties, right? Lubricant should have some properties. The main properties are explained, or properties are given here. Number one is high boiling point and low freezing point, right? So if the lubricant is ended up boiling, right? If the lubricant is boiling, means it's going to actually vaporize. So if it is boiling or freezing, that means freezing means it's going to turn into solid. If either one of these things happening in between the vehicle's operating conditions, then there will not be any lubricant. So it's not accepted. And high viscosity index, that means it should have a very high viscosity value. So viscosity value we should be higher, so it can actually provide the necessary lubrication, right? And thermal stability. Thermal stability means since lubricant system is working inside the engine, right? What they call this? It should not actually turn into some other um, substances while in operating conditions. So because of the high temperature, the um, lubricant should not be broken into some other materials and form other contaminants inside the engine bay. Engine bay means it's actually working over 500 degrees Celsius. So at that temperature, if this lubricant is not thermally stable, it may actually end up creating unwanted contaminants inside the engine. Hydraulic stability, it should be able to actually flow at all temperature. It does not matter whatever the temperature, should be able to actually flow. Free flowing effect should be there. That's what I mean by hydraulic stability. Corrosion prevention. So inside the engine, it should actually try to, it should not actually uh, it should not actually support corrosion. So these chemicals inside of this material, inside of the um, lubricant should not help the corrosion. It should actually prevent the corrosion. High resistance to oxidation. Oxidation means again lubricant may actually break into like solids. So to avoid that, it should not actually oxidate. Anti-foaming ability. So when engine is working inside, as if you can remember this image. So for here example, right? So when this crankshaft and piston is actually moving, right? When the piston is moving, crankshaft is actually going to go and it's going to contact, right? And when the vehicle is actually moving, it's going to actually lubricants is actually going to move left and right, right? So that could end up foam. It could end up creating foam inside the lubricant itself. So to avoid that, it should not actually foam. Foam should not be generated. Foam means, you know what's foam, right? Like bubbles. Bubbles should not actually generate. Bubbles means it can't maintain the pressure. It could not be pumped as well. So those are the properties a lubricant should actually have. If we so in order to get these lubricant properties, lubricants have to actually have different additives may be even added. So some additives are actually added just to increase the viscosity index, or to increase the corrosion prevention, anti-foaming ability. So after adding all of these additives, lubricants only can be used in the vehicle. So lubricants actually grade based on the operation, based on what application they are suitable for, and the grades are actually depends on viscosity, right? The grading is actually depends on the viscosity itself. So I think you might have actually heard this few years back, especially like few means not actually few decades back. We had only single grade lubricants, right? Single grade lubricants. Now we have multi-grade lubricants. So lubricants are actually graded by different entities, but mostly used by the Society of Automotive Engineers grading for automobile applications. So according to them, SA, we call it as SA. So we have single grade lubricant and multi-grade lubricant. So the difference between the single grade and multi-grade lubricant is the viscosity, right? Viscosity difference between the extreme temperatures, like small, low temperatures and high temperatures are different for each of these oils. But if you go for multi-grade lubricants, they can actually operate in low temperatures as well as higher temperatures, or two different extreme temperatures without having much of a change in the lubrication, sorry, viscosity. So that's what nowadays actually being used, right? So in order to achieve this multi-grade lubrication capability, they actually add something called viscosity index additives are added, right? By adding viscosity index additives, we actually have multi-grade lubricants. So in multi-grade lubricants, usually we call multi-grade lubricants as notation of the multi-grade lubrication is actually this one, right? So the one shown here, right? So in the red color, it's actually given the cold temperature, and the green color, it's given the cold temperature gauge. So for each lubricant, it has these two grades. It can actually maintain these two grades at low temperatures and high temperature. So W of this low temperature gauge actually means, right? What that actually means is W means winter. W stands for winter. So when it means when you go to buy a lubricant, it says say W 5W20. So what it means is it has grade of 5, right? It has 5W, 5 means grade of 5 at cold temperature, and grade of 20 at hot temperatures, right? So this lubricant can maintain that. But if you can remember, like single grade lubricant, it's just called as something like SA40. It's very SA40 or SA, and something like SA20. That's what the single grade. Single grade also actually came as SAEW, sorry, 20W sort of things, but nothing beyond that. So what that means is this particular lubricant, right? This particular lubricant is only delivering this grade of viscosity at low temperature, right? Low temperature. It's not good to use at high temperature applications, right? So that's what actually this means. So nowadays we actually have this SA lubrication system. So SA have this what do you call this standard for lubrication grading, which is correct, SAE J3000. Yes, SAE J3000 is the lubrication grading uh, protocol or guidelines. Right? If anyone wishes, you can actually read that, but I'm not exactly sure whether they allow anyone to like download it unless you are a member of SAE. Anyways, so that's the basics on lubrication system. With that, I'm actually finishing today. I didn't expect to take more than this, but anyway, it didn't work. So, anyways, I'll discuss the cooling system class next time.